let's talk about something that sounds quite complicated. It's called MRO, or Method Resolution Order. What does it mean? Well, I have an example here for you. Let's say we have a class of A, class of B that inherits from class of A, does absolutely nothing. And then we also have class C that inherits, again, from A. And then finally a class D that inherits from B and C. So we have two classes that do absolutely nothing, and then a class A and class C that have the same class object attribute. And I've actually drawn out how this relationship looks like. You see that D has multiple inheritance from B and C and C inherit from A. And MRO, or Method Resolution Order, is a rule that Python follows to determine when you run a method, which one to run. When you have such complicated inheritance structure, MRO is a rule that says, hey, do this, and then do that, and that's the method that you should run. Let me show you what I mean. Let's say I wanted to do print d.num. What do you think will happen here? Let me move this out of the way or comment this out. If I run this, can you guess what's going to happen? If I click run, I get 1. Is that what you expected? Let's look through this. D inherits from B and C, and then those inherit from A. So we get 1 because the MRO, the Method Resolution Order, is that it doesn't go D, B, A. Instead, it goes D, B, C, A. Let's think about this a little bit more. MRO is simply saying what's first in line. If things are common between classes, methods, or variables, or attributes, what should I pick? And there's actually a good way for us to check this. If I do MRO and then run it like this, if I click run, look at that. This is the order, or the MRO of this class. It says, hey, I'm going to check D first. If you call, let's say, d.name or d.num, I'm going to check main.d first. So I'm going to check this class. Then I'm going to check main.b. So I'm going to check B. And then I'm going to check C. And then I'm going to check A. And then finally, I'm going to check the base class object. Again, we've seen that before. It's the base class that all objects in Python inherit from. So that's the order that it checks for num. If we pass all of these, and I click run, I'll get an error. D has no attribute num because it went through all this path, even checked the base object, and never found num. If I did something like str, if I click run, this works because it goes all the way through the inheritance chain and then gets to the base object, and the base object actually has this. So it does an error out, and yep, you can use the dunder string. Now, I found a great example here to show you why inheritances can be confusing and why things like MRO you might want to avoid, or at least be conscious of. So let's copy this code, and let's just remove all of this, and we're going to play a little game. Now, this syntax looks like this. So this is the inheritance model of what we just created. Looks pretty confusing, doesn't it? So if we do M here, and we check the MRO, or Method Resolution Order of M, what do you think the order is going to be? Pause the video here and try to guess what the order will be. Ready? Let's do m.mro. And by the way, another way of doing this is to use the dunder, MRO. And let's print this. All right, let's check this. So the first thing we have is M. All right, we check M. And then we check B. We check B. All right. And then we check A. So we check A here. And then we check X. X over here. Then Y. Then Z. Then the class object. Is that what you guessed? Let's look at the code. Why this order? Well, the order is because of the way that we're passing in the parameters. You see, B is passed before A and Z. So that means the order of MRO is going to be B, then A. But hold on. After B and A, what was that? Well, after B and A, we have class X. Why did X come before Z? So instead of going to Z, let's make this a little bit bigger. Instead of going to what we would have thought would be Z, it goes to X, then Y, then Z, then the object. This is because of the algorithm that they use for doing MRO, which is called depth first search. Now, this is beyond the scope of the course. But as you can see, it's quite a bit confusing. And as a matter of fact, Python actually changed the MRO rules from what we had previously in younger versions of Python. So this is another one of those things that got updated. But the reason I'm showing you this is because you're never going to get tested on this stuff. If you're writing code where the inheritance looks like this, I argue that you're writing bad code because this is overly complicated. We haven't even written any code actually inside of these classes, and it's already confusing. So MRO is there as a way to define what order you're going to inherit in, and you can always use the MRO function or dunder to check this. But the reason I brought it here is not just trying to confuse you. The reason is that it exists, however, you should not structure your code in this way. This doesn't mean that this doesn't happen in the wild. Yes, it does. But at least you have a way of checking and maybe debugging your code when you see a problem like this. I'll leave a resource for you about MRO if you're really curious and you really want to understand how this algorithm works and how this order is actually determined. But the key takeaway is that this is the way that Python works to determine, hey, when you call a method or an attribute, this is how I'm going to look up the hierarchy of inheritances. All right, if your brain hurts, don't worry, so does mine. Take a break, and I'll see you in the next video.